don't forget, because this is an actual word problem situation, don't forget your units. So when we're talking about volume, what happens to the units?
Cubed.
They should be cubed. So this is 904.78 inches cubed. All right, so the next one, okay, be careful on the next one because they give me a diameter. What does that mean? You have to half it because my formula is for radius and they gave me a diameter. So the first thing I'm going to do is half my diameter, and that would make my radius 4.6, and that's what I'm going to use in my formula. So 4 pi times radius squared. That gives me a surface area.
Can I see your calculator?
Uh-huh.
Oh, okay.
And you can use the pi button, or if you just want to use 3.14, that's okay right now. We're just, the decimals will be a little bit different, but not enough to matter. So, all right, surface area, that gives me 265.90 centimeters squared, because that's surface area. So now I'm going to do the formula for volume. I'm actually just going to go up and grab the one I used a minute ago, because I don't want to retype all that. Okay, is everybody okay so far? All right, so now we're going to do the cantaloupe. They gave me radius this time, so I get to use what they gave me. Again, I just went up and grabbed it because it just makes it faster. Everybody knows how to do that, right? Okay. Okay, we good so far? All right, so on problem number 2, it tells me they've given me a function, volume in terms of surface area, equals 0.094 s to the 3/2. This formula can be used to approximate the volume if you are given the surface area. So if I don't have the radius, if they don't give me the radius or the diameter, but they give me the surface area, I can use this formula to calculate my volume. So right here, they have gone ahead and started the basketball for us. So the volume in terms of surface area, they're replacing it with the surface area of the basketball, which was 452.4. And then we're just going to plug that in our calculator. So now, you can type it as 3 divided by 2 up there. You can do alpha y equals 1, you get a fraction bar, and 3 over 2, or if you know the decimal for 3/2, which happens to be 1.5, you can do it that way. But the same answer doesn't matter. Whatever you want to do. All right, now if you look at what we got when we actually knew the radius, we got 904.78. When we've used the formula based off of surface area, we got 904.58. Not exactly the same, but it does say right here we're using it to approximate the volume. So they're basically telling you it's not going to be exact, but it's going to be real close. So let's do the same thing for the cantaloupe. All right. And again, it's not exactly what we got, but it's really close. I got 1767.15. This time I got 1766.56. But they're real close. Is everybody sort of okay so far? Plugging stuff in? Anybody have a question? No. Okay. All right. So on number 3, suppose we have a spherical balloon and it has a surface area of 325 centimeters squared. When it's deflated, they want us to use the same formula we've been using to determine how many cubic centimeters of air it would take to fill this balloon without stretching its surface. So they gave us our surface area, so I'm going to be looking for the volume with a surface area of 325. So I'm just plugging in 325 this time. Did y'all get 550.74? All right, so number 4. So on problem number 3, we didn't blow the balloon. We only blew the balloon up until it was about to start stretching, but just till it was full, not starting to stretch. But on number 4, it's saying more and more air can be pushed into the balloon until it reaches a volume of 2,000 cubic centimeters. So they want us to use the formula to figure out if we did that, if we blew it up to 2,000 cubic centimeters, what would the surface area be? So this time they're giving me a volume and they're wanting me to find surface area. So that means I'm working this problem backwards. I have a volume and I'm looking for the surface area. Bless you. So I'm going to do 2,000 equals 0.094 s to the 3/2 power. And I'm solving for s. All right, so if I'm solving for s, I'm trying to get s by itself. What would you do first? Right, we want to get rid of the 0.094, and that's being multiplied by the s, so I'm going to divide to get rid of it. All right, that gives me a really big number. 21,276.596 equals s to the 3/2. Now remember, my goal here is to get s by itself. And right now it has an exponent of 3/2. When I say s by itself, I really mean s to the first power, right? X by itself is really x to the first. So I need it to be s to the first. And right now it's to the 3/2. So think way back to like 4th, 5th grade, whatever. Fractions. When can I say that a fraction equals 1?
When it's over the same number?
When it's over the same number. And right now it's not. I got a 3 over a 2. But if I could get a number over the same number, then it equals 1. So I'm going to raise this to a power, and I need it to equal 1. So I'm going to raise it to what we call the reciprocal power. I'm going to raise this to the 2/3 power. And if I do anything to one side of an equation, I have to do it to the other. So I'm going to raise the other side to the 2/3 also. Now when you do that, that would make this s to the 6 over 6, which is s to the 1, which is what I needed. So in my calculator, I already have that number, so I'm just going to hit the caret key so that I can do 2/3. And I get 767.84. And this would be square centimeters because we're going from cubic, we're going from volume to surface area. Are y'all okay? Not bad, right? Pretty easy. If they've got numbers, they're pretty. All right, so this is what we did. The first thing we had to do, remember, we divided by the 0.094. That was in order for us to isolate the variable and the exponent. So we needed that exponential piece by itself. So here's one of the things for sure that's been happening on the quizzes for the last couple of days that I've noticed. If I have this, what does that 4 belong to?
The X.
Yeah, just the x. It doesn't belong to the 2. So if I have this, 2x to the negative 3, who's upset?
The X.
The x. So the only thing that moves is the x. 2's fine, it stays where it is. So that's why on this, we can get rid of the 0.094, and it doesn't affect the 3 halves, the exponent, because that exponent doesn't belong to the decimal. It only belongs to the s. So once we've divided, then we get s to the 3 halves power. We raised both sides to a reciprocal power. That means you just flip the fraction over. So we, in this case, we raised this to the 2/3 power. And if you do it on one side, you have to do it on the other. And then that gave us our solution. All right. So we're going to work a couple of these together, and then I'm going to let you work a couple of them by yourself. So what do I do first on A? Subtract the 11, because we want to isolate the variable with its exponent. So I got a to the 1/3 equals 5. And I want to raise this to the reciprocal power, so 3. It does. And I have an answer bank over here, so I can mark that one out. All right, let's see. Since I'm not going to do them all with you, let's skip down to F. What do I do first on F? Plus 8. Divide by 3. And now what? Yep, now we're going to raise it to the reciprocal power, so to the 3/4 power. Everybody okay?
Go ahead to the last one.
Sure. All right, so go ahead